Hello, conceptual physics students. As we begin chapter 4, we have a vector practice set of problems. And I've given you 3 problems in class to kind of start things out. And I think it'd be a really good idea if I show you how to do number 2. Suggestion, as usual, click the pause button when you do part of it, and then you can do some of the vector work yourself. But here goes. So I've written out on this problem right here that we are doing problem number 2. It is the addition of 2 vectors, 430 newtons at 37 degrees south of west, and we're adding that. That's all we're doing is adding vectors to 760 newtons at 28 degrees north of west. I like to make a scale for every problem I do. The scale should be 1 centimeter equals something. In this case, 1 centimeter equals 100 newtons is very reasonable. And so I'm going to draw these vectors, adding them head to tail. And I'll draw the first one. The order doesn't matter. So the first one I'd like to start with is the 430 newtons. In order to do that, I need a ruler and a protractor. So hopefully you have one of those. So when I use my protractor, the first thing I'm going to do is have an axis, and it can be anywhere on the paper. And since I'm going to be going westward, I'm going to start my axis right there. And the first one I'm going to use is 37 degrees south of west. And what that means, 37 degrees south of west, means you start with west and measure 37 degrees south of west for my first vector. So I'm going to start with west, and I look west. So that's here where it says 180. Then I just count by tens. 10, 20, and then I want 37 degrees. So that's 30, 35, 36, 37, and let's make a little dot there. Okay, I'm going to draw a vector that's exactly 430 newtons long. Well, according to my scale, every one of the centimeters is 100 newtons. So I place my ruler there, and I'm going to measure it to scale: 100, 200, 300, 430, and that goes right about there. So I'll make a line that goes right from there to there and actually draw an arrow. This is my 430 newton vector. When you add vectors, you always add them head to tail, which means you begin the new vector where the other one stopped. My new vector is 760 newtons, but the most important starting place is 28 degrees north of west. And so I will put my protractor and make a new axis, new coordinate axis right there. It's got to be lined up with the grid coordinates on my graph paper. And it needs to be 28 degrees north of west. That means this time I will start with west and measure 10, 28 degrees north of west, and make a mark. Again, I'm going to do 760 newtons, which means 7.6 centimeters. So I start with and I can start with anywhere, as long as I start with someplace, and I just randomly start right there, and I will go 7.6. So this is 100, 200, 300, 400, 500, 600, 700. Now this would be 800, so 760 is right about there. Okay, I will draw my line in, make an arrow. My answer vector. So the answer vector is the vector that goes from the tail of the first to the head of the last. So that answer vector will start at the very beginning and will go out to the end of that vector. And I'm just going to highlight that by drawing it in red. To measure how long that is, I use my ruler and my scale, and again, I'm counting by hundreds. So I'll start right here, and I'll just count by hundreds. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 1,000. So we have just a little more than 1,000. You could write 1,000. Here, I would say 1,020. So 1,020 newtons is the answer. But the direction is very important. So to find the direction, I place the protractor at the tail of my answer vector. Notice, my answer vector is less than 10 degrees. It's about 5 degrees north of west. I would start with west and measure 5 degrees north of that and write my answer at 5 degrees north of west. That's the answer to the problem, and that's the answer vector. You've now added a couple of vectors. Congratulations. Try the rest on your own.